So children, let us try to solve some interesting numericals from worksheet number 2 of Law of Conservation of Momentum. So here we go. So children, before starting with, let us recall back the conservation of momentum principle. What is that? The total momentum before collision must be equal and opposite to the total momentum after collision. That is before collision. If two marbles are coming in contact, means collision will be saying. Okay. Anything that happens, that may be any situation that happens, like it may be some impact, it may be some explosion. Based on that, we need to consider that system. So first, moving to the first numerical, that is the object at rest. So initially, how was the condition of the object? It was at rest condition. Suddenly explodes into 3 parts. How many parts? 3 parts. With the mass ratio 2:1:1. So what is given, children? So if one mass is 2m, the other mass is m and the other mass is m. So if you take the ratio, it will be 2m:m:m, nothing but 2:1:1. So that is what is given. So the parts of equal masses move at right angles. So what is given means, so here some body it was given, and what it is given means some mass is m, the other mass is also m, but the third mass is given as 2m. Like this it is given. Okay, 2m, m and m. And according to the condition, the parts of equal masses. So here these two are equal masses, and it was given that they both move at right angles. So suppose if this mass move at this direction, positive x-axis, the other mass would have moved in the positive y-axis or negative y-axis. Anything you can consider. Let us suppose it as positive y-axis. Now you are asked to find the speed of the third particle after explosion. So let us suppose that move with right angles to each other with equal speeds. So suppose if this is moving with speed v, this must also move with some speed v. So this is first particle, second particle. Let us suppose this as third particles. Okay. So this is first, second and third. 3 parts. First part of equal, some mass m moving with speed v along positive x-axis. Second body of mass m moving with speed v in positive y-axis. And you are supposed to find the speed of the third particle having mass 2m. So this is your given data. So initially what was given, children? Initially the 3 parts were at rest condition. Rest condition means speed is 0. As I told you, according to the law of conservation of momentum, the total momentum before impact must be equals to the total momentum after impact. Here the impact means explosion. Before explosion equals to after explosion. So before explosion, all together total mass is supposed to be concentrated. What is the total mass, children? 2m, m and m. Total mass. Okay. And what condition are there? 2m plus m plus m. Together they are forming a system which is at rest. Rest condition means 0, whose total speed, the complete speed of the total body is 0. Why? Because it is at rest condition. Must be equal to. So must be equals to what happened, children? So they all are moving with some speeds in different directions. So first body moving with mass, having mass m, moving with speed v. Suppose it as on x-axis. Positive x-axis, we consider it as a I cap. Positive y-axis, let us indicate with some j cap. So mv, mass into velocity along I cap, and here mass into velocity. Along which direction? This direction is indicated by j cap. Now the third body of mass 2m, whose velocity unknown, let us indicate this velocity for third body as v3. So direction will represent it later. So according to the given condition, we wrote this. So clearly anything, this is nothing but 2m plus m, 3m plus m is 4m. 4m into 0 is 0 equals to mv I cap plus mvj cap plus 2mv3. So let us try to bring this 2mv the other side. Then it will become minus 2mv3 equals to, what is left over, children? mv I cap plus mvj cap. This is what is given. Well, so taking MV common, we no need. Okay, V3 must be equals to, bringing this minus to the M the other side. It will be how much, children? M by minus 2M V I cap plus M by minus 2M V J cap. That's it. Okay, I just brought minus 2M to the other side, right side. Then it will become the denominator. So solving here, we get, so V3 is found to be, this M and M gets cancelled. Here also M and M gets cancelled. Minus, bring the above. Then you have minus V by 2 I cap. Here also minus, carry it upwards. Then minus V by 2 J cap. So this is the value of speed. But here only magnitude was asked in the given. Then we have the, in order to find the magnitude of V3, root over coefficient square. What is the coefficient here? Minus V by 2. So minus V by 2 whole square, plus again here also we have minus V by 2 whole square. That's it. So this, after simplification, you'll get minus V by 2 whole square is V square by 4 plus again V square by 4. Therefore, the value of magnitude of V3 is equals to V square by 4 plus V square by 4 is 2V square by 4. Okay. So how much is that, children? 2V square by 4 under root. Solving, we get 2 goes 2 times. Okay, so root, what is left over? Root over V square by 2. What is root over V square, children? Root over V square is V and root over 2 is root 2. Hence, the magnitude of the velocity or the speed of the third particle who having mass 2m is found to be V by root 2. Hence, option number 4 must be true. Okay, is that clear, children? That's it. Initially at rest condition, the others are moving with different speeds in different directions. Simply solve for that and find the magnitude of the speed of the third particle. Moving ahead with the second question. A man and a cart move towards each other. How are they moving? Towards each other. That means in the opposite direction. If one is moving in the positive direction, the other must be moving in the negative direction. The man weighs 64 kg and the cart weighs 32 kg. So, masses of man as well as cart is given. The velocity of the man is 5.4 km per hour as that of the cart is 1.8 km per hour. So when the man approaches the cart, he jumps onto it. The velocity of the cart carrying the man will be. So what is given, children? Here man is given whose mass is found to be 64 kg and whose speed of the speed of man is found to be, speed of man, like we write it as Vm, given as 5.4 km per hour. That's it. This is what is given. And what else is given? A cart is being given. This cart is also moving, whose weight is found to be 32 kg and the speed of the cart is given as 1.8 km per hour. So this is your given data. But according to the question, what they gave is the cart and man moves towards each other. If the man supposed to move in positive direction, the cart must be moving in the opposite direction. This is speed of man and here it is speed of cart. Okay, so when the man approaches the carts, when they both approach each other, he jumps onto it. The latter case, what happened means, second case, the man jumps inside the cart. So now what is the total mass? Total mass is mass of the man along with mass of the cart. Okay. Now you are asked to find the velocity of the cart carrying the man. So now they might be moving with some common velocity. Together they are moving, so some common velocity. So based on that, we have to find out the common velocity of the two. Okay, children. But if you observe that here it was given in kgs, 32 kg and 64 kg, whereas the speeds are given in kilometer per hour. So let us convert everything in the common system of units. So clearly we have, so Vm, velocity of the man, is given as 5.4 kilometer per hour. So kilometer per hour, kilometer means how much meter ma? 1000 meter per hour can be written as 3600 seconds. So zeros gets cancelled. 2 goes 5 times and 2 goes 18 times. So together it is 5 by 18. So remember always children, whenever you would like to convert kilometer per hour in terms of meter per second, simply multiply this with 5 by 18. So as we know that this 18 goes 3 times, so hence it is 0.3. Therefore 5 into 0.3 is 1.5 meter per second. Earlier it was in kilometer per hour. Now I have converted in meter per second. Similarly, speed of the cart is given as 1.8 kilometer per hour. To convert in meter per second, let us multiply the same with 5 by 18. This 18 goes 0.1 times, and hence 0.1 into 5 is 0.5 meter per second. Okay, well, now applying the law of conservation of momentum. According to the law of conservation of momentum, the total momentum before impact must be equals to the total momentum after impact. Before the impact means before the man has jumped into the car, this is the individual conditions. So initially, if I suppose the mass of the man as m and mass of the cart as some small m, then clearly mass of the man into speed of the man, okay, and mass of the cart and speed of the cart, as they both moving in the opposite direction, if this is taken as positive, the other must be taken as negative. So this minus, I hope you understood, because this is moving, both are moving in opposite direction, positive and negative, equals to, now the man has jumped into the cart, so together they are moving. So now the combined mass m along with m, together they are moving with the common velocity v, which we need to find out. So substituting all the values, children, what is m given? Mass of the man is given as 64 kg, speed of the man is taken in meter per second as 1.5, minus mass of the cart is 32 kg into speed of the cart is 0.5 must be equals to mass of the man plus mass of the cart into common velocity. So we need to find out the common velocity. So let us solve, children, by substituting. This can be written as 64 into 1.5. Can I write it as 3 by 2 for easier simplification? 3 by 2 or 1.5, both are same, minus 32.5 can also be written as 1 by 2 equals to 64 plus 32, that is 96 into V. So let us try to solve the same. Well, 2 goes 32 times, whereas this 2 goes 16 times. Further multiplication gives 32 into 3 is 96 minus 16 equals to 96 into V. So 96 minus 16 is nothing but 80 equals to 96V, or V is equals to 80 by 96. You got the answer in meter per second, but if you observe the options, it was given in kilometer per hour. So again we need to convert this meter per second into kilometer per hour. So how to convert this, children? So we have V, in order to convert in kilometer per hour, we have 80 by 96 into. So earlier we, in order to convert kilometer per hour into meter per second, we multiplied and divided with 5 by 18. Now the reverse way, meter per second into kilometer per hour means it should be multiplied with 18 by 5. So remember this, children. Okay, reciprocal. Well, so simplify this. So how much are we getting after simplification? This is 5. 5 goes 16 times. Well, and here 18 is there. We'll go in a easier method only. 3 will go simple. 6 3 is 18 and here 32. Okay, and this again 16 goes 2 times and 2 goes 3 times. Hence, we found that the speed of the common speed of man along with the cart is found to be V is equals to 3 kilometer per hour. Must be your final answer. Hence, option number 3 must be true. So option number 1, that is 3 km/h must be true. Is that clear, children? The next question. Question number 3. A bomb of mass 6 kg initially at rest. Again, a bomb is given. Initially, how was it? It was at rest condition and explodes into 3 identical fragments, similar to the first problem, but 3 identical, same masses. One of the fragments move with velocity 10 root 3 I cap meter per second, another with a velocity of 10 j cap, and the third fragment moves with the velocity of magnitude. You are asked to find out. So it's all similar to the first numerical. So let us try solving the same. So children, again a bomb is there. So this bomb is now exploding into 3 equal parts, M, M and M. Okay, total mass is 6 kg. So now 6 by 3 equal parts means 2 kgs each. Okay, one of the fragment moves with a speed of 10 root 3 I cap. The other 10 j cap, and the third one you're asked to find the speed. Okay, well, so initially how was the body? The bomb was initially at rest condition. So clearly the total momentum before collision, so all together it was there. All together means total mass. So total mass is nothing but m plus m plus m, that is 6m. And it was given that 6 kgs, so 6, the total mass is, let me tell you like this, all together they were there. Okay, m plus m plus m, okay, into, initially it was at rest condition, must be equals to. Now what happening? First mass moving with the speed of 10 root 3. I'll write it like this. This be some V1, V2 and V3. This is M1, M2 and M3. M1, M2 and M3. So M1 moving with speed V1, M2 moving with speed V2 and M3 you are moving with speed V3, which you are asked to find out. So this is nothing but 3m, and but 3m is itself is given as 6 kgs. Okay, so total mass is m plus m plus m is nothing but 3 times of m, that is 3m into 0 and 3m. The total mass is given as 6. 6 into 0 is 0 equals to, first mass is m moving with speed 10 root 3 I cap plus the second mass again m moving with speed 10 j cap. Third mass is again m moving with speed unknown. This is what you're asked to find out. So 0 must be equals to, what is common in all my children? M. This must be equal into 10 root 3 times of I cap, m taken common 10 j cap plus m taken common V3. So this m, if it is brought to the left side, 0 by m will be 0 equals to 10 root 3 I cap plus 10 j cap plus V3. So let us, keeping the V3 the other side, bringing these values to the left side, we have minus 10 root 3 I cap minus 10 j cap will be equals to V3. So this is the value of V3 both in direction as well as magnitude. So you are asked to find out only magnitude according to the options. So the magnitude of V3 can be found by taking the square root of minus 10 root 3 whole square plus 10 whole square. That's it, children. Well, squares of the coefficients as they are perpendicular to each other. The magnitude of V3 can be written as like this, equals to root over minus 10 whole square is 100, root 3 whole square is 3, and this is 100. Hence V3 is found to be root over, this is 100 into 3 is 300 plus 100 is 400. Hence V3 is found to be square root of 400 is 20 meter per second, and hence option number 2 must be true. Okay, well, the next question, what is given, children? A bullet of mass 20 grams is fired from a rifle of mass 8 kg. So rifle means the gun is given, whose mass is 8 kg with a velocity of 100 meter per second. The velocity of the recoil of the rifle is, so look at the question, children. So a rifle is there and from this rifle a bullet is being shot. A bullet of mass 20 grams is given, fired from a rifle of mass 8 kg. Mass of the rifle small capital M and bullet mass small m, I suppose. 100 meter per second. The speed of the bullet is whose mass is given to be 20 grams and the speed of the bullet is given to be 100 meter per second. So bullet speed VB I am indicating. Mass of the bullet, small bullet will be smaller size, so small m I indicated. Rifle will be bigger in size, of whose mass capital M I indicated with, and it was given as 8 kg. The velocity of the recoil of the rifle is, you are asked to find out the recoil speed of the gun. Okay, VG equals to how much? Recoil means minus VG you are asked to find out. Children, simple. According to the law of conservation of momentum, the total momentum before firing the bullet must be equal, and opposite to the total before firing must be equal to the total momentum after firing. So initially, if you observe that the bullet will be inside the gun, okay, inside the rifle. So whenever the bullet was inside the rifle before firing, they both are at rest condition. So clearly we have the total mass of the bullet and the mass of the gun as well as the bullet into initially speed whatever they are having must be equals to the mass of the gun into the speed of the gun plus mass of the bullet into speed of the bullet. This is your condition. So before firing and here after firing. Momentum before firing must be equals to momentum after firing. So mass of the gun is given as 8 kg. Mass of the bullet is 20 grams. So 20 grams can be converted into kgs as 20 into 10 power minus 3 kg. Okay, 20 by 1000 kg. So here it is 20 into 10 power minus 3. Initially they were at rest condition. So when the bullet before firing, both bullet and gun is at rest condition. Again mass M means mass of the gun is 8 kgs into speed of the gun that we need to find out. Okay, plus mass of the bullet is 20 grams, 20 into 10 power minus 3, and the speed of the bullet is given as 100 meter per second. So everything if you simplify, this will be 8 plus 0.202, okay, and nothing but 8.02 into anything into 0 is 0 equals to 8 VG plus here 2000 into 10 power minus 3. Here 3 zeros and here 10 power minus 3. 10 power minus 3 can be written as 1 by 1000. 10 power minus 3 I wrote it as 1 by 1000 and all zeros will get cancelled. So what you are left with, children? You are left with 0 must be equals to 8 VG plus 2. Or if you bring it to the other side, minus 8 VG will be equals to 2, or V minus VG, because you're asked to find out the recoil speed of the gun. So minus VG must be equals to 2 by 8. So 2 by 8 is nothing but 2 goes 4 times. So this is nothing but 1 by 4, and 1 by 4 is nothing but 0.25 meter per second. So what is the final answer, children? 0.25 meter per second. Hence, option number 1 must be true. Is that clear? So, before firing, both together they are there in rest condition. After firing, they both move in opposite direction with different speeds. So, you're asked to find the recoil. If gun speed means VG, recoil speed of means minus VG. That's it. Well, the next question, 5th one, a spacecraft of mass 2000 kg moving with a velocity of 600 meter per second. So what is the mass of the spacecraft given as 2000 kg and speed of the spacecraft is given as 600 meter per second. What happened? Suddenly it explodes into two pieces. How many pieces? Two pieces. One piece of mass 500 kg is left stationary. First mass is at rest, whereas the velocity of the other you need to find out in meter per second. Well, so masses are given in kgs, okay, and speed is given as 600 meter per second. Everything in SI system. Spacecraft, whatever you consider, okay, there is a spacecraft, children, and this spacecraft mass is given as 2000 kg. So spacecraft mass is 2000 kg, moving with a speed of 600 meter per second. Suddenly it explodes into two different parts. Okay, one piece of mass, how much mass? 500 kg is left stationary, whose speed is found to be 0, whereas the velocity of the other part must be. So you don't know the mass of the second part, some m, and the speed you are asked to find out. Of course, children, so this is explosion, during an explosion, before explosion and after explosion. You need to apply the conservation of momentum before explosion and after explosion. Before explosion, here if you consider the two pieces masses as one is m1, the other is m2. Okay, so what happened is m1 and m2 be the masses of two different parts. So initially the two masses were combined together. Both the masses are present here and moving with some common velocity must be equals to. Later on what happens? The first particle mass into speed of the first particle and second particle speed of the second particle. So this is a generalized condition. And what is the total mass given to be here? m1 plus m2 together it was given as 2000. Together they are moving with speed 600 meter per second. m1, if you consider m1 is this and m2 is this, m1 speed is mass is 500. Initially this was after explosion, this came to rest, and m2 mass some m. But what must be m, children? You must be knowing this. The total mass is 2000 kg. If one mass is 500 kg, the leftover mass must be 2000 minus 500. It's nothing but 1500. So m must be equals to 2000 minus 500. So m is equals to m2 equals to m equals to 1500 kg. Hence mass, second mass is, even though it is not given, you can calculate by 2000 minus the one part 500. So 1500 into the speed you have to find out. Clear? So clearly we have 2000 into 600 must be equals to, this will be 0, leftover is 1500 V2. That's it, children. Well, so let us solve the same. We have V2 can be found as, this V2 can be found as 1500, taking the other side you have 2000 into 600 whole upon 1500. That's it. So solving this, 0 and 0 gets cancelled. 5 goes 3 times and 5 goes 4 times. 5 4s 20 and 2 zeros. Again this 3 goes 2 times. Hence your final answer for V2 must be equals to 400 into 2 is found to be 800 meter per second. So the correct option must be option number 2, that is 800 meter per second. So children, moving to the next question. Question number 6. A person weighing 60 kg in a small boat. So what is given here? A boat is being given, children. Boat of mass is 140 kg. Mass of the boat is given as 140 kg. Inside the boat there is a person whose mass is given as 60 kg. Mass of the man is found to be 60 kg. Okay, both are at rest condition and this man throws a 5 kg stone. So what are they doing? So this person throws a 5 kg stone. The stone weight is 5 kg and it was thrown with a speed of velocity of 14 meter per second. The stone was thrown with a velocity of 14 meter per second in the horizontal direction. The velocity of the boat immediately after the throw is. now when the stone is being thrown, the man inside the boat, that means man along with the boat will move in the backward direction. As the stone moves forward, the man along with the boat will move in the backward direction. But initially all the three under rest condition. So this part is clear. So if we suppose the mass of the boat as MB, mass of the man as MM, and mass of the stone as MS into the initially whatever the together they are in some speed moving, okay, rest condition. So this speed because all together in rest condition, let me drop it as 0. All the three together are rest condition. Rest means 0. Must be equals to, so as the stone is moving forward, mass of the stone along with which the stone is being moving, that is MS into VS plus this, as the stone moves forward, man along with the boat moves backward. So man, mass of the man along with the boat must move in the backward direction with some speed. Let us suppose it as V. I hope the statement is clear. Substituting all the values in the above equation, we have mass of the boat is given as 140, mass of the man is given as 60, and mass of the stone is given as 5 into 0 must be equals to stone mass is 5 kg, stone's velocity is 14, mass man 60, mass of boat is 140 into the velocity with which the man along with the boat together they are moving. So 140 plus 60 is 200 plus 5 is 205 into 0 is 0 must be equals to 5 into 14 is 5 4 20. So this is 70 plus 60 plus 140 is 200 into V. So bringing this 200V the other side, 200V must be equals to 70, or V can be written as minus 70 by 200. So after further simplification, we have 7 upon 20. 7 by 2 is 3.5. So this is nothing but minus 0.35 meter per second. So minus indicates that as the stone moves forward, the boat along with the man moves in the backward direction. Hence it is very clear that the velocity of the boat along with the man after the throw will be 0.35 meter per second in the backward direction. Hence option number 3 must be true. Magnitude is how much speed? 0.35 meter. If they are asking for direction, it will be in the opposite direction of the throw.